So I request you all to please download this zip file satellite_data.zip from the shared folder day 5 and upload it in your drive. So in today's lab session, we will develop one convolution neural network. And
so can I say, I'm so sorry,
yes.
I'm interrupting you. Can I say something here? So participants, there are many important applications of satellite image analysis. In the present context, when the security of our country, of any country's boundaries are important. And apart from that, you know that there are several environmental issues that are cropping up because of the global warming. So especially wildfire is a point of concern for everybody around the globe. So we thought that in this version of machine learning for computer vision, we will be focusing on smoke smoke detection from satellite imagery, right? So today, Poornima has purposely taken this satellite data to help you out with building a first model for classification of images into containing smoke and non-smoke. And then we will continue with the satellite data in our later sessions as well. Thank you, Poornima.
Thank you, ma'am. So some of you wants to know that how we can use this particular data without downloading and uploading. That we will explain you. So you must have the shared folder. So you can just paste the shared folder link in your drive. And then as this is my incognito tab, I have to sign in. Now I will sign in from my personal account, not the institute account. So in your case, your drive should be opening like this. What I will do in the shared folder, I will click on this ML for CV folder, and then I will add shortcut to my drive. Directly to the drive. I'm not changing the path. I'm using the path ML for CV Fab 2022 over here in directly drive. So you can see now this is the folder we have. But I don't have write privileges over here. I cannot write anything similar to you all. So what I will do, I will only read the data from these folders. So in my drive, I'm creating another folder. Here I will create a Python notebook. So I request you all to please create a new Python notebook over here. Click on this plus new, go to more, and there you will find Google Collaboratory that will open a new Jupyter notebook. Maybe I'm using incognito, that's why it is causing the issue. So I'll open a new window. So this is the folder, ML for CV. And the folder we have created is I think this one we have created. So here I am creating a new Python notebook. I don't know. Okay, this is because of the quota exceed. I have exceeded the quota. So please create a new notebook. And rename it to either convolution neural network or CNN. Then to access the data set, first of all, you have to change the runtime. As we are using images in today's lab session, you have to work with GPU, that is graphics processing unit. So from runtime, change your runtime type to GPU. All of you, please do it. Please change your runtime to GPU over here. From hardware accelerator, make it GPU. After this, the next step is mount your drive. So please click on this files menu, then click on this mount option. Connect your drive to your Google Drive. Then go to the place where you want to work. So in my day 5 folder, I'll somebody. You have to change the runtime from change runtime option. The hardware accelerator should be GPU so that you will have the capabilities of graphics processing unit. So I've created a new folder. I'm copying the path of this folder, and then I will go to that particular folder. I request you all to please change the current working directory using cd command to the place where you want to save the results. If you will not change this, there are chances that your results will not store permanently. From this runtime menu, you have to click on change runtime and then GPU. That's all you have to do to select GPU. Next step is change the current working directory using %cd command. Then paste the path where you want to save the partial or intermediate results. Then as we have saved the shared drive, here you can see the shared drive is this file, this ML for CV folder. This is the shared folder we have. Sameer sir, can you please paste the path of this folder again? Many of them asking.
Yeah, I'll do that.
Thank you. Okay. So now we will access the data from that folder only. So all of you can do the same step. As you can see, in ML for CB folder in day 5, the lab folder, this is a zip file. So we have to unzip. It contains your images inside multiple folders. So for unzipping, this path will be separate in your case. This path will be the path of your drive, not the my drive path. So you can change it according to your convenience, wherever you want to save the practice this notebook. There you can change this. After that, you have to unzip the shared weights, the shared data. So for that in Linux, we have unzip command, exclamation mark unzip, and then here you have to provide the path of zip file. So all of you, please go to the shared folder. There you will find the zip file. I'm giving the path of the shared folder. When you have added shortcut in your drive, you must have ML for CV Fab 2022 in your drive. Inside that, go to day 5, then lab, and then this is the file satellite_data.zip. I'm copying the path and then pasting the path over here. So this is the path. If you have used the same way, then your path will be same. Please run it. What is the issue? Is not able to find. So let me first copy it. CP. So using CP command, you can copy the this zip file satellite_data.zip into your drive. So I am using the same. I'm using exclamation mark CP and then pasting the path of zip file. Here there are multiple spaces available. So to exclude those spaces, I'm using a slash over here. So it will exclude those spaces and read it as a single parameter. And this is the destination. So the destination is /. I'm writing so that it will paste it in the current working directory. And then I will run ls command to check whether satellite_data is there or not. So you can see in my case, it is copied. All of you, those who have not uploaded due to some internet availability issues, they can use this step. Next is unzipping the data. So for that, exclamation mark unzip space satellite_data.zip. So it will unzip the images. Please do it. I'm pasting all the commands in the chat box also so that there will not be any typo. So as you can see, unzipping is done in my case. So now I will comment this line. So for commenting, use control ? or write one hash just before the line so that no need to unzip again. After unzipping, when you rerun this ls command, you will find out that there is another folder created with name satellite_data. Inside satellite_data, there are two folders. One is non-smoke and one is smoke. When you go inside smoke or non-smoke, sorry, I have to use satellite/ smoke or non-smoke. So there are multiple JPEG files are available. Please check with ls command that do you have this zip file and the unzipped folder with you or not. I will wait for you all. When you are done with this part, please let us know that you have the data. The link is same. The data set is available in day 5 folder. Those who have joined late, maybe they don't know the path. The data is there in day 5 folder. Day 5 folder satellite_data.zip is there. Please download it and upload it in your drive. Then you have to unzip it using unzip space the path or name of the zip file. When you are done, please let us know. We are waiting for your response so that we can proceed further. So in today's lab, what we will do, we have the data in this folder, which consists of two separate folders. One is smoke and one is non-smoke. In smoke folder, you have all the images of with all the images which contain smoke, and in non-smoke, all the satellite images which are having non-smoke are available. So I will go to, I will show you one of the image. So this is the data, satellite data, smoke and non-smoke. The dataset link is available in the shared Python notebook. So these are the satellite, some of the images which have smoke. And non-smoke satellite images are here. The data set is already shared with you all. These are some images. After this, what we have to do, we have to split the data in training, validation, and testing. Up to yesterday lab, what we have seen that the data we have splitted was in training and testing data. In today's lab session, somebody from some of you were asking yesterday that the data is strictly present in train and test, how we can randomly assign it. So that we will do today. Yes, if you don't want to follow these steps, you can skip. Just use this unzip command to unzip the zip file. So next is we have to split the data in training, validation, and testing. As our data is inside folders, and these folders represent the class name. Smoke is a class and non-smoke is another class. Suppose you have 10 classes, so 10 folders will be there. In each folder, you will have the respective class image. So in Python, we have one library available to split these folders in training, validation, and testing. So let's first of all install the package. Install split folders. Please install this package so that we can split the data in training, validation, and testing. So validation data we will use after each epoch to check the performance on unknown data, and test data we will use at the end of the training. After installing this package, next you have to import the split folders package. Import split folders. And when you go to this split folder package documentation, you will find out that it contains two possibilities. One, you can divide the images in fixed number, that if you have 100 images, you can divide the images in 80 images for training, 10 images for testing, and 10 for validation. Or if you don't know how much count you want, you can divide those images in ratio as well. So we are here using the ratio one. So split folders dot ratio. This, as you can see, it is suggesting us first parameter is input. So input is the path of your input data, your folder that contains all the images in multiple classes. So satellite data will be the path of your input folder. The output folder path you can change, or accordingly you can set. I am setting it as split data. So a new folder will be created in my current working directory named as split data, and from that we can access training, validation, and testing data. Next is while splitting the data, if you want to use the seed value to make a consistency in the data, you can use seed parameter over here. So in seed, you can use any number. Based on that number, your randomization will be fixed. So let's use any number. Next, the last parameter we have to pass is ratio. In which ratio you want to split. So if you want to split the data in training and testing, you can write 0.73, 0.03, like 70%, 30%. If you want it 80-20, you can write 0.8, 0.2. If you want the data in training, validation, and testing, you have to write 0.8, 0.1, 0.1, or 0.7, 0.1, 0.2, whatever the ratio you want for training, validation, and testing. So I'm using 0.8 for training, and then 0.1 for testing and 0.1 for validation I'm using. And then I will run the cell. Please do the same. I have pasted the code in the chat box. It will not take more time. Just import split folders. Then using split folders, make it ratio. And then the input path, output path, seed value, and the ratio. 4 parameters you have to pass. The total should be 1. It should not be randomly assigned. The sum of the ratio should be 1. So can we proceed further? So let's proceed. The next step is we have to read the data from this split data folder. So when you go to the folder where you have created this split data folder, this is the folder it has created, split_data. When you go inside this, you will find that 3 folders are there. One is validation, one is training, and one is testing. Inside training, Again, two folders are there. One consists of smoke and one is non-smoke. Similarly, in validation, you have one smoke and one non-smoke folder. In test, you have one smoke and one non-smoke folder. So in your case also, it will be same, but there are chances that your results may not reflect back to your drive. It takes some time to write the data in drive. So don't panic. You can check it from here that whether this split data is created or not. So now our data is ready to go in the model. So we have to read the data and pre-process it. First of all, we will do the code in TensorFlow. If time permits, we will start it with PyTorch, and if it will be 8, then we will start or resume the code from here only in tomorrow's lab, because in tomorrow's lab we have transfer learning. That will not take a lot of time. So we will do this same code in PyTorch as well, as many of you want that PyTorch should be covered. So we will try it, and we will definitely do it in PyTorch as well. So first of all, in TensorFlow, we are going to use Keras. So from TensorFlow, we have to import Keras. And for data pre-processing, if you have images, then a separate library or separate package is available for image pre-processing. If you are working with text, then separately you have multiple options available in Keras that have text pre-processing steps available. So we are going to use image pre-processing steps. For that, we have to write keras.preprocessing.image. There is a function named as image data generator that we will use here. It's a like available generator that we can use. But if you have some specific requirement, you can create your own generator. This generator is for image classification task. Here in this image data generator, you can use it for image pre-processing, image data augmentation if you want to work with that, you want data to be splitted, or you want to resize the images, you want to normalize the images, you want horizontal flip, vertical flip, multiple options are there. So if you want to use any of them, you can use image data generator. Here we are just normalizing the image. So we will use a parameter available as rescale, that here we will divide all the pixel values by 255. So you have to write 1 by 255. So it will divide all the pixel values by 255. This is your normalization step. If you want to like horizontal flipping, vertical flipping, crop, or any other type of augmentation, that also you can use here. Currently, we are not using. We will go ahead with this only, the normalization process. And I'm going to store this as in a local variable or object of this image data generator. I'm naming it as data gen. This is the data generator I'm using for all training, validation, and test data. If you want image data augmentation in your code, then you can write separate data generator for training that will have the augmentation part, and a separate data generator for testing and validation that will only have the normalization step. After this, Using this data generator, we can read the data from folders. So let's do that. First of all, let's read training data and store it in a local variable train_data. So for that, you have to write datagen dot. As the data is inside directories, we have to use flow from directory. This is a function we are going to use. It takes multiple parameters as input. So the required parameter, we will give it here. The first parameter is the path of your images. So you have to give the path of training directory. Our data is here in this folder, split_data / train. This is our input data for training images. Next is the target size. Target size is the size in which you want to feed the images in your model. So you can use 32 cross 32, 64 cross 64, n number of dimensions you can set. So here I'm using 224 cross 224. I'm using it from yesterday because this, when you see many of the standard architecture, they are using 224 cross 224, nothing else. So you can change it. Availability of images or the model size, you can change it. After this, the next parameter is batch size. In how many batches, in a single batch, how many images will be there. So I'm writing it as, you can use 2, 4, 8, 16. I'm using 8. Next is class mode. The class mode can be binary if you are working with binary data, or categorical. So we are using categorical here. And then shuffle. So by default, shuffle is true. But I'm writing here true for training data. So when you are using this data generator or flow from directory function, what is the main utility, or why we are using it? The reason is that your images are of large size, maybe in GBs or MBs or GBs when you are counting all the image size. But your RAM is limited. So you cannot read all the data at once. So Keras has provided you this image data generator function that will help you to read the data in batches from the provided path. So you will not exceed with RAM availability. So many of you must be reading the images in the same way we have done in yesterday's lab, but that is not the correct way. You have to read the data in batches from the memory, from the storage, because of the low availability of the RAM. Same way, let's read the validation data. The only change here is to change the path. All the other parameters will be same. And third is test data. And here I'm writing shuffle as false, so that your results will not change when you recheck or rerun the code. So this is all you have to do. I'm pasting the code in the chat box. So if you are not able to see it properly, and I will also decrease maybe because of a large line code, you are not able to read it. I request you all to please do the same. The difference between training, validation, and test data is that the training data is used to train your model. You have the actual output, your model will predict the one, you will compare both, and then based on the error value between the predicted and actual one, your back propagation is performed, weight update process is performed. And like that, based on the availability of training data, your model will learn the features of your data. After, once your training data is feed in the model completely and one epoch is ended, you will use your validation data to check the performance on unknown data. So validation data is not from your trained data. That will be treated as unknown data. Your performance of the model, trained model after first epoch is evaluated on validation data. Again, in the next epoch, your batches will be feed into the model. Your model will again do the weight update process and the performance will update or change. After ending of the epoch, the validation data will go to the model and check the performance on unknown data without any weight update process. Like that, the validation data will be checking the performance after each epoch. Once your model's training is done, maybe for 5, 10 or 100 epochs, then you will evaluate the performance on test data after the training. So this is the difference between training, validation, and test data. We shuffle training data and validation data. If you pass this shuffle as true in for validation and training, that means after each epoch, your data is shuffled in batches. In different batches, your data will be shuffled. So we are using shuffle as true because if same data will pass again and again, there are chances of overfitting. But when you use data in random shuffle manner, then your model will learn the features in a better way. So as you can see, we have 324 images in training in 2 classes, 40 images for validation in 2 classes, and 42 images in test data for testing in 2 classes. The batch size is here. This depends on the availability of RAM. If you have large size RAM, you can set it as 32, 64, 128. If you have very small RAM and your model is big, that it will take a lot of space in your main RAM, then your batch size should be 248 like that. So batch size decides the number of images in a single batch. If you have, for example, if you have 42 images in total and you have set the batch size as 8, so there will be a single batch of size 8. Like that, multiple batches will be created. 6 batches of such images will be created if you will use 42 images. One image will have 8. Sorry, one batch will have 8 images in it. So can we go ahead? Now we have read the data from the memory. Next is have to create the model. So for model creation, as we have told you that in Keras 2 types of model creation capabilities are available. So today also we are going to use sequential model. The functional API one we will use in transfer learning while writing the transfer learning structure. Or here also we can use, that is not an issue, but let's use the sequential one only. So let's create a local variable that will have your model, writing CNN model, and then from Keras dot models, we are going to use sequential type of model, where you can use add function to add multiple layers in the model. So there are 2 ways of passing input layer or input in your model. One way we have done in yesterday's lab, where we have given separate one parameter in dense layer named as input shape. Another way we are using today, that is in Keras, we have input layer available. So we are going to use that input layer. Keras dot layers dot input. This is a layer. It takes shape as in parameter. In shape, we have to pass the shape of the image we are giving, that is 224 cross 224 cross 3. So this is our input layer. Next is, as you have seen the convolution neural network structure, it has multiple convolution layers and some max pooling layers, max pooling, average pooling, or any type of pooling layers available. So it is a stack of multiple convolution and pooling layers. In this model, we are creating a small model as the number of images are very less. A smaller model can also work well. Let's first of all create a small model so that we will know that how the output volume is calculated and how the number of parameters are calculated in the CNN model. As ma'am has already explained in the theory part, it will be the same way. You have to calculate the output volume and the number of parameters. So let's add the first convolution layer. CNN model.add Keras.layers. First of all, we will use convolution layer. So our data is in the form of images. So we have to use con2D layer. Here, the first parameter is the number of filters you want to use. Next is the size of the filters, then the stride value, the padding you want to use, and number of parameters are there. Activation function and weighted initialization, kernel initializer, bias initializers are there. So the first is number of filters. Let's use, first of all, 8 filters over here. The filter size we are going to use is 3 cross 3. Then stride will be 1 cross 1. So I'm not using the parameter strides. Okay. Next is the activation function. Let's use activations. So in hidden layers, we have to use value as an activation function. Then somebody is asking what is dilation rate. Your filter, if your filter is of size 3 cross 3 and you are using dilation, then your filter will be dilated or expand based on the dilation rate. If you will make it as 2 or 3, so your 3 cross 3 filter will be expand to 5 cross 5 or 7 cross 7. And then in place of the actual 3 cross 3 image, it will be worked on the expanded image pixels. So dilation, you can study more up in research paper that how you can use dilated filters. The filters are the weights we are going to use. Yes, you can say in what we can say. In artificial neural network, whatever represent the neurons, the connectivity is weights. So filters are the weights that we will learn in the back propagation or the entire process.
So Poornima, whenever you're answering, please read out the question because they might not have written to everybody.
Yes, ma'am. Okay, ma'am.
Thank you.
Thank you, ma'am. So filters are the weight matrix. So let's use here the kernel initializer as random normal. Let's add another convolution layer with 16 filters and other parameters we will set as it is. So 2 convolution layers we have added. Next, let's add one pooling layer or max pooling layer. We will use keras.layers. Max pool 2D. And the size we are going to use is 2 cross 2. So first let's create the model up to this part only. Then we will add more layers once after the complete process will be done. So you can see we have started with image size of 224 cross 224 cross 3. Then we have moved 3 cross 3 kernel in a convolution layer, and total number of filters are 8. We have added another convolution layer of size with filters of size 3 cross 3, and total number of filters are 16. Then in the third layer, we have used max pooling of 2 cross 2. So here also you can use multiple convolution and max pooling layers. Then when you are done with the convolution and max pooling layer adding, then at the end, as you can see that your data is in 2-dimension format, but for classification, you have to convert your data in 1 dimension. So you have to either flatten the output of the last layer, or you can convert it using global average pooling or global max or pooling min pooling. You can convert the output of the last layer in 1-dimensional format. So first of all, let's use the flatten option. CNN model.add layers.flatten. We have to flatten the output of last layer to in the 1-dimensional format. Then here also you can use multiple 1-dimensional layers, like that is dense layer. So let's add one dense layer. Layers.dense. And here you have to write the number of neurons. Let us use 16 here. And then the activation function you will use as ReLU. And let's add the output layer. CNN model.add. The output layer will also be the dense layer. Keras.layers. Dense. We have 2 classes, so I'm writing 2 here. Again, we are not solving it as binary classification problem. Here 16 is, so the question is, what is 16 here? Here we are writing 16 as number of neurons. In the output layer, we will use softmax as classification activation function. Another question is, what is the purpose of dense layer over here? If you will not use this dense layer, then also your model will work well. But to learn more features from the data, more features using your NN model, you can use dense layers as well. Not only convolution layers in CNN model, you can also use dense layer over here. And for output also, you have to use dense only if you want to use the classification of your data. As your data is in one dimension, the output vector is one, that is the class value. So you have to definitely get the output as 1D. So that's why we are using dense here. Now our model is completed. So let's check whether the model is correct or not. The model is created. I'm copying the model in the chat box, waiting for you all to do the same. Meanwhile, I will answer the questions. So as ma'am has already told you that there is no such rule available to decide the number of layers, the number of filters, but generally it is 2n plus 1 to set the next layer number of filters for number of neurons. Here you have to try with 18, like 8, 16, 32. Yeah, you can try with multiple combination, and whatever suits best in your case, that will be the best performing model. So generally, we start with 16 or 32 or 64, and then as deeply we go to the convolution layer, we increase the number of filters. Yes, ma'am.
And if the data is having a lot of variance, so in that case, you can take more filters from the very beginning also. Some people take, no, this Narayan Tazi, we have been telling from day one, all the speakers who have spoken about convolutional neural networks or neural networks have been telling time and again that there is no hard and fast rule for selecting the number of filters or any hyperparameter, right? So hyperparameter selection is, there's no hard and fast rule because the data itself is having a lot of variation in different types of domain. You can have different types of data. So there's no specific rule. So some people are asking again and again how to decide number of filter, how to decide the bias, how to decide the number of neurons. There's no such rule, my dear friends. You have to look at your data. If it is having a lot of variance, include large number of filters from the very beginning, like you have 64 filters from the very beginning. So can we have different batch size for validation or test? This is the question that is coming here. And where is the bias in this CNN is another question that is coming. Poornima?
Yes, ma'am. So bias you can initialize from here, like we have initialized kernel, but default value of bias initializer is 0. So I'm not rewriting the same. The bias will be initialized whenever you have created a convolution layer. The number of filters you will create, the same number of bias will be created by this convol 2D layer. So you can set same as kernel initializer. Another parameter you can set as bias initializer equal to 0. So zeros, generally we set it as starting from zeros. Another question is flat and dense layers are same as normal layers. So these dense layers are the densely connected or ANN layers, not the convolution layer. As we have in convolution layer, our data was in image format or two-dimensional format, but in dense layer, our data is converted in one dimension. So we will explain how to calculate trainable parameter once all of you will able to do when you are done with this particular code. Yes, you can see the network diagram. There is one library available in Keras through which you can see the network diagram. We will tell you first of all, we are just trying to cover the basic, whatever is compulsorily we have to do. In Keras, diagram structure is available. The data augmentation part, if you want to do, you can just write here. Somebody is writing, are we covering the data augmentation? So you can see when I have clicked over here, so it is suggesting me horizontal flip, vertical flip. So if you want to use data augmentation, image data generator, you can write the shift range, rotation range, shear range, and the fill mode, horizontal flip. By default, it is false. If you want the image should be augmented by horizontal flip or vertical flip, you have to set these parameters as true. So like that, you can apply data augmentation. We are not going to use augmentation here because this is a practice problem, and the number of images are very small, and I think currently we have a span also very limited. So let's go ahead without data augmentation. If needed, use. Some other questions there. Can we have different? Yes, you can have different batch size. Somebody is asking different batch size can be possible for validation and test. Yes, you can set for validation and test as 2, 4, or 1 is batch size. Next question is, can we directly apply features in the sequential model? If your data is in 2 dimensions, you can definitely create a CNN model. So another question is, can we create a spatial transform network in Keras model? You can create. So can we go ahead now? Ma'am, we have to give a break of 1 or 2 minutes, or we can proceed? Participants, do you need a break of 2 minutes, or we can proceed? Okay, then many of you are writing to proceed. So we are proceeding. We have done with model building. Next, we have to understand how the output volume is created and how the output volume is calculated, or output shape is calculated, or the number of parameters are calculated. So let's start with output shape. The input shape is 224. Number of filters are 8, and filter size is 3 cross 3. Stride value is 1 and padding is 0, as you can see. Input is 224. That is n. You must have understood the formula explained by ma'am in the first session. To calculate the output shape, the formula is n minus f plus 2p upon s plus 1. So here n is 224. F is 3. So n minus f, you will have 221. plus 2p. Padding is 0, so it will become 0. So it will be 221 only, n minus f plus 2p upon s. It will be divided by s, that is stride. Stride is 1. The default value of stride is 1. So it will be 221 divided by 1. And then the complete output is added with 1. So you will have 222. So as you can see, our output is 222 cross 222. And the depth is 8 here because of the number of filters. We have filters as 8. So that's why the output shape is 224 cross 224 cross 8. I think I have to explain again for the next layer so that it will be more clear. In the second hidden layer, that is this con 2D, the input is of size 224 cross 224 cross 8. Sameer sir has written the formula in the chat box, so you can go through that. That will be much easier to understand. N is here, the image size or N is 222 minus F, that is filter size, is 3. So 222 minus 3, that will become 219. Then filter size will be added with 2 into filter size will be added to the output, that is n minus f plus 2p. So padding is again 0. So it will be 219 upon s. So stride upon stride, that is 1. So it will be 219 only. And at the end, you have to add 1 in the output. So it will be 219 plus 1. So that's why it is 220 cross 220. And then whatever number of filters you will apply, that will be the depth of the output shape. So we are applying 16 filters. So that's why the output is 220 cross 220 cross 16. So this is the way you can calculate the output shape. Here in the flattened layer, here first of all, let me explain this max pooling layer. So here in this max pooling layer, we are using 2 cross 2. So in 2 cross 2 portion, max pooling is performed like that. Your entire image will be converted into the new image of size 110 cross 110, and here the depth will be same and there will be no parameter involved while performing max pooling operation. Next is the flatten layer. It will just flatten the output of last layer, that is this max pooling layer. That is, it will multiply all these dimensions, that is 110 cross 110 cross 16 will be multiply, and it will give you 193600 as the dimension. Next is we are adding one dense layer. So that will be only 16, and this is the output layer. The out shape will be 2 only. So this is the way you calculate the shape. Next is number of parameter calculation. So if you have understood in the ANN part, the same way here, the parameters are calculated. So in case of convolution neural network, the parameters are the filters. The number of filters available in the convolution layers, the size of the filters are the number of parameters. So in the first convolution layer, we are using 8 filters. Each filter is of size 3 cross 3. One filter size of 3 cross 3, but it will apply to the depth of the input. So the current depth is 3. So single filter will be of size 3 cross 3 cross 3. So let me write it in the chat box. Earlier I have not written. So one filter will be of size 3 cross 3 cross 3, that is 27, one filter. 27 values will be there in the single filter, and each filter will have one bias. A single filter will have one bias. We have such 8 filters available. So the number of trainable parameters here will be 8 multiplied by, or what we can say, 3 cross, let me write it as 3 cross 3 plus cross 8 plus 8. I have written in the chat box 3 cross 3 cross 3 will be the size of single filter, multiply by 8, because one filter is of size 27. Such 8 filters are there. So 3 cross 3 cross 3 cross 8. One filter will have one bias, and total 8 filters are there. So that's why plus 8 will be the number of parameters in the first layer. Is it clear to you all? In the second hidden layer, we have 16 filters. Each filter is of size 3. Here the input depth is 8. So to calculate the number of parameters in second hidden layer, we have to consider the filter depth as 8. So 3 cross 3 cross 8 is the shape of, or the number of parameters involved with single filter. 3 cross 3 cross 8. Such 16 filters are there. So it will be 3 cross 3 cross 8 cross 16. Each filter will have one parameter. So total number of filters are 16. So plus 16 will be there. So in the second hidden layer, we will have 3 cross 3 cross 8 is single filter size. That 16 filters are there. Each filter have one bias. Total 16 biases will be there. And this will be the number of trainable parameters in the second convolution layer. So this is the way you calculate the output shape and number of parameters in convolution layer or convolution neural network. So can we proceed further? There is one query from Justin sir. So I'm unmuting you. So you can ask your question. Yes, please.
Madam, Madam, my name is Dr. Justin. Hello.
Yes, sir.
Hello. Madam,
Yes, sir, you can ask.
In the CNN input layer, we have 8 filters, right?
Yes, sir.
So after CNN input layer, we'll be having 8 images, right?
8 images will not be there. Feature maps will be there, sir.
Yes,
Not
yes,
images.
8 feature map. Yes, 8 feature map images, right? Or size 220 cross 220, 221 cross 221, right?
222 cross 222.
Okay. So the next sequential layer is CNN1 layer, right?
This one with 16 filters.
16 filters. Does this 16 filters we apply on CNN1, CNN input layer outputs or directly on the image?
Yes, sir.
So if we apply individually on the outputs of input layer, then there we have 8 images. All that 8 images we apply this 16 filter means it should be 16 into 8 normal.
No, sir. This is not the way. This will not be considered Yes, sir. This is not image. This is a feature map, you can say, a single feature
Okay.
map.
No, actually,
All-
his
Yes, ma'am.
query is different, and he is perhaps not he's asking what will happen to these 8 channels that are produced. So that's
Yes,
what
sir.
he's asking. Yeah. Can I, if Poornima, if you just unshare, can I share the
Yes, ma'am.
screen?
Yes, ma'am. Yes.
Ah,
So let me share the screen just for your, perhaps Preeti Madam
Okay.
has already covered this, but
Okay.
suppose you have 8 channels
Okay.
coming as output. So let me take these 8 channels, right? So these are 8
Yes.
channels. She has covered
Yes,
already.
yes. Ah, okay.
So suppose the filter is working here in this part, right?
Okay.
Filter is working here. You get one value out of this. So it's a
Okay.
3x3 filter. Suppose you get one
Yes.
value. Let this value be, say, 5.
Okay.
The same operation is done on the second channel,
Okay.
the
Yes,
filter.
okay.
You get some value, say -3.
Okay.
You add them. And then
Okay.
similarly,
So this.
8 channels. So
Okay.
this
Okay. Okay.
value will keep. And finally, suppose this is 7.
Okay. So now it's clear, ma'am. Now it's clear.
Okay.
Okay. Thanks. Thanks.
Yeah, please continue.
Okay. Thank you very much.
And Poornima,
Thank you.
there are a couple of questions which are sent to me also, perhaps. I do not know. Let me check.
Yes.
Let me check. To everyone is okay. I saw some questions specifically to me, so I'm not able to trace back. Okay, you please continue. I think if we have missed any question, please feel free in asking again. Okay.
Yes, ma'am. Thank you, ma'am. So we have calculated the output shape and number of parameters. Now the next is model training. Before training, we have to compile the model by giving the hyperparameters like optimization function, the loss we are going to use, the matrix we have to calculate. So sir, you can ask your question in the chat box or at the end of the session. Can we continue? Because ma'am,
Yes, yes. Yeah.
Ma'am, there, sir want to ask another question. Same, Justin, sir.
So you,
Maybe
as you
can-
said, we can ask it then. Yeah, no problem.
Thank you. Next is we have to compile the model with the optimizer, loss function, and the matrix we want to calculate. So for that, first of all, let's initialize one optimizer with the learning rate. Let's use Adam as an optimizer here. Yesterday, maybe we have used SJD in yesterday's session. So from Keras dot optimizers dot Adam, here we will pass learning rate as 0.001. I'm writing it in a local variable. Then our model name is CNN model. Then we have to compile it with the parameters. The first one is optimizer. So we will use optim here. Next is the loss function. So when talking about the image data generator, it provides you the output in the form of one hot encoder. One hot encoders are nothing, but it makes an array of size the number of classes, and whatever value is available or whatever class is present in that particular data, that index is marked as 1, all other index are 0. So suppose you have 10 classes in your data, a vector of size 10 will be created for output, and class number 3 is present. Suppose class number 3 is present, then index 3 will be marked as 1. All other 9 index are 0. That is one-hot encoding. So image data generator will give you the one-hot encoder based output vector. So here the loss function will be categorical cross entropy loss. Yesterday we have used sparse categorical cross entropy loss because we were using 0, 1, 2, 3 like that, not the one-dimensional one-hot encoders. So categorical cross entropy loss will be here. Next is the matrix we want to use. So matrix we will use here is accuracy. The measure we will use is the performance measure will be loss and accuracy in this case. Let's compile the model. I'm copying the code in the chat box. All of you, please follow the same steps. Create one optimizer. Then using the optimizer, loss function and matrix, compile your model. So can we go ahead? Yes, you can use here precision recall F1 score. The metrics are available in the Tensorflow website. You can use. If you want to use multiple metrics here like precision, F1 score, recall, those metrics are available in Tensorflow. You can follow the Tensorflow's website or Keras website to access multiple performance metrics. So there is another question that if more than one classes are available in the data, then how the one-hot encoding will be there? So in this problem, multi-label object, that is the same object or same image is in the same image, more than one classes are present. In that case, whosoever class is present, maybe class number 3 and 7, that will be marked as 1, 1. Index 3 and index 7 will be 1. All other index in the size of 10 vector will be marked as 0. There is another question, where will we take categorical and where sparse categorical. So sparse categorical cross entropy loss is considered when your data is in the form of 0, the output is 0, or the first label is 0, the second label can be 1, then 0. For fifth image, maybe it is 1, for again it is 0, like that. For first image it is 0, for second it is 1, for third it is 2, like that your data is present. This is for sparse categorical cross entropy loss, when your labels are in the form of these numbers. But when your data is in one-hot encoder, then you have to use categorical cross entropy loss. So this 0 can be, in case of one-hot encoder, the 0th index will be 1. All other, maybe you have 5 classes, so all other index will be 0. So this will be the representation of this 0. For this 1, the representation of one hot encoder will be like that. For 2, it will be like this. So it is nothing but 2. If more than one classes are present in the same image, maybe 2 and 0, then this will be 1. So this is for multiple classes. So this is for categorical cross entropy loss, and this is for sparse categorical cross entropy loss. So let's go ahead. There is no more question. Now we have to train the model. So for training, fit function is available. CNN model dot fit. First of all, you have to pass the training data that is there is in train underscore data variable. Then you have to pass the validation data. So validation data is valid underscore data. Then you have to pass the batch size. So I'm using 8 here. You have to pass the number of epochs. Number of epochs, let's set it as 5. And I'm storing the result in a local variable history so that we can further plot the training graph. Let's run it. So ma'am has written that on Sunday we will have quiz at 11 a.m. for half an hour. This is the line you have to write to train your model. CNN model dot fit, pass your training data, validation data, batch size, and epochs. It will take some time. If you have any query, please let us know. So there is another question. Please create the graph. Sir, we will create the graph maybe after end of the up to the prediction. It will hardly take 10 minutes to complete the evaluation and prediction. But let us complete that. Then we will do it if you permit us. The training and validation graph we will create now. So top 1 and top 5 accuracies also you can select from here. In the matrix parameter, you have to pass from TensorFlow. Top 1 accuracy parameter is there. So this is, I'll explain you. This is not 41 epoch. So this is epoch 1 of 5. This is first epoch. Here it is written as 41. That is the number of batches. In a single batch, you have 8 images. And as we have some 300 some images, so total number of batches it has created are 41. So that's why 41 is written over here. It is taking 42 seconds to run this code for single epoch. The initial loss is 0.4854. The training accuracy is 77.16. Then the validation loss is 0.35. Validation accuracy is 85% for the first epoch. Then you can see loss is decreasing and accuracy is increasing for training. and for validation, it is stable. Then the loss is decreasing and changing after each epoch. And at the end of 5th epoch, we got the loss, training loss as 0.0537. The accuracy is 99.07%. For training data, for validation, we have loss as 0.04 and accuracy is 100% for validation data. So this is the case after 5th epoch. Next is, we can plot this loss and accuracy in the form of graphs using matplotlib library that we will do now. Yes, the validation accuracy, when your validation accuracy is higher than your training accuracy, that means your model needs more training. So let's plot it. Import matplotlib.pyplot splt, then plt dot. So let's first of all access the data from this history variable. It has 4 data available in dictionary format. In history, another dictionary that is named as history is present. So let me first print the data. So you can see it has a dictionary named as history in it, which has accuracy as key, loss as key, validation accuracy as key, and validation loss as key. So one by one, we will access all the data. Accuracy is history dot history, and here the key is accuracy. Similarly, we will have validation accuracy. And in the same way, we can access loss as well. So to plot accuracy and loss for training and validation, we need in x-axis, we need the epochs count. So the epochs will start from range 1 to up to the length of the count of maybe accuracy plus 1. So we are starting from 1 and going up to 5 because it excludes the last value. So length of accuracy is 5. I'm writing as 6. So it will start from 1 and go up to 5. Next is, let's plot it. So plt dot plot, x-axis will have epochs, and in y-axis we will write accuracy. Then you can pass label as well. Label is training accuracy, and this will be your validation accuracy. If you want to use legends, so you can use plt.legend. If you want to give the labels to your x-axis and y-axis, so you can use plt.xlabel. Next label, we can write epochs. And y-axis, we have to write accuracy. To give title to your graph, you can use plt.title. And then we can use plt.show. So this is the graph for training and validation accuracy. Similarly, we can use for loss. I will paste the code in the chat box also and allow, like, give some time so that you can also do the same. So, and this is the graph for loss. We have executed the code for very less number of epochs. There is another question in the chat box that how we can check the response time of the model. So to check the response time, you have to first of all import the time, calculate the start time, and then when your model is executed completely, calculate the end time, then subtract end time to the start time, then you can calculate the response time of your model. So I request all of you to please do this code of plotting your training and validation graph. So there is one error Sangeeta ma'am is getting, that why argument is not supported. So please check in the fit function. You should use the generator. You have to pass the generator. If you are not passing the generator data, then you can get the error. There is another question in the chat box that can we import our own optimizer? You can also write your own optimizer and pass it in the model compile parameter over here. Here you can pass the custom optimizer. Another question is how can we improve the accuracy? So in this case, as this is a practice problem only, so if you are, it is not the complete data we are using. If you will use the complete data, then you have to train the model for some more epochs, maybe some 20, 30, 50 or 100 epochs. First thing is that. Second is your model structure will be changed. It will have some more number of layers. You have to try with multiple combination to get the best result. And there is one doubt in the chat box that it is getting the parallel lines in the training data. That means your performance is not improving, that you are not, there is nothing your model is learning. So please fine tune your model. Fine tuning means change the number of layers, and then the filter count, filter size, number of filters. Then your model will performance will improve. Another question is that how can we get the features? Features like if you want the output of a particular layer, then you can access if I want output of this CNN model, feature of maybe second last layer, so I will write CNN model dot layers minus 2. So like this is the way you can access the features or output of a particular layer. How can we choose the optimizers? So optimizers in Keras, there are multiple optimizers available: SGD, ADA, grade, ADA, delta. You have to compare the performance of all the optimizers, and then you can see that which one is working well in your data set. Here it is showing as another question is that the epoch is showing as 1, 1.5, 2, 2. So in the legend, you can perform the changes that in which difference you want your y-axis data will be plotted. Another question is that which one is the best X-ray image feature selection algorithm? So I cannot say, I don't know which one is the best.
In fact, there's nothing like best in ML. It depends on the data distribution and also on the data characteristic of those samples and the distribution. So nothing can be considered as best in any, it's not a deterministic problem. So somebody, Santosh ji, is writing, kindly explain epoch and batch size. He has written to me, Poornima.
Yes, ma'am. I'll explain.
Yeah.
And ma'am,
how to visualize hidden layers is
yes,
Satya. Visualize hidden layers.
Ma'am, can we cover this in tomorrow's lab, that how we can visualize the feature maps of hidden layers?
Sure.
So, sir, we will cover it, that how you can print the feature maps of hidden layers.
Can we use NNN for noise removal and CNN for noise removal and threshold? Yes.
That also, ma'am, we have in upcoming labs.
Yeah.
There is another question, ma'am. Can we include autoencoder in this model? So autoencoder session we will have in next week.
Separate session, yeah, next week.
Yes, we are going to predict. We will predict, ma'am. Once we will explain this batch size and epoch, then we will predict on unknown image. So the question is, explain epochs. So epochs are the number of times your complete data will go to the model for weight update process. In a single epoch, the whole data will go once. Then in the second epoch, your data will be again shuffled in the batch size of 8 cross 8. Sorry, in the batch size of 8, in a single batch, you have 8 images, and such that your entire data will reshuffle. And then again, the training process is performed, or weight update process is performed. Like that, we are using epochs as 5. So in each epoch, your data is shuffled, as we have used shuffle as true. And the complete weight update process is performed for 5 such epochs on whole data set. So let us now go to the prediction. First of all, let's evaluate the model performance on test data. So CNN model dot evaluate on test data. So it is giving the accuracy as 100% in this case. So that means the model is overfitted. The model is very small. Sorry, here we are using the number of parameters as 3 million. It is a huge number of parameter we are using to extract the feature of a very less number of images. So that's why it is giving us 100% accuracy. Next is prediction of on unknown data set or on a new image. So for that, we will use CV2, import CV2. Then from using CV2, we will read one image. First of all, let's read the image from I'm taking one smoke image. Then we will convert the image in RGB color space. Next is we have to resize the image as per the model input size. So CV2 dot resize the image into the size of 224 cross 224. Next is we have to normalize the image. We have done the rescaling in the generator part. Similarly, we have to normalize the image over here. So image is image divided by 255. And then we will show the image. So this is the image we are going to use. You can select the image from your data or any image from website or internet. As your CNN model works with in the form of batches. So first of all, you have to reshape your image in the form of input to your model. So let me first tell you the shape of input image. That is image dot shape is 224 cross 224 cross 3. But your model takes the data in the form of batch, comma, height, width, and depth. So you have to convert this data in the form of batches, comma, height, width, and depth. So batch currently is not available. So we will reshape it. img.reshape as 1, 224, 224 cross 3. And then, so we make sure whenever you are predicting on unknown data, you have to follow all the steps you have done with the training and training data and the validation data. The same steps you have to follow for the unknown data set. The pre-processing part and then the input shape should be same. Now let's predict it. There is a question, why are we reshaping? The input shape is 224 cross 224 cross 3, but your model takes the input in the form of batches, comma, in image size. So batch is currently not available. The batch size is not there. So we are making it as 1, 224 cross 224 cross 3. I will tell you when you will pass actual image and when you pass the reshaped image, what is the difference? The actual image will not be processed. It will give you the error. So let's run CNN model.predict. Let me first check on the actual image. It will give us error of shape. You can see it is giving us that it needs the input should be in the shape of none, 224, 224, 3. But it is 32, 224, 3. So what we have to do? We have to pass the reshaped image. So you can see it is giving us one output. I'm storing the output in a local variable. I will paste the code in the chat box once we are done. Then when we print the output, you will see it is giving you probabilities. This is one probability. This is another probability it is giving. So whichever probability is higher, the image belongs to that particular category. So for that, to get the highest probability index, we will use numpy argmax function, import numpy as np dot argmax on output. So it will give you the index. So it is giving us index 1. To check what is there in index 1, you have test data or train data, any type of generator you can use, and then you can write class indices. So 0 for non-smoke and 1 for smoke. That means this particular image belongs to smoky category. So let me now copy paste the code in the chat box. So if there is a question how to find good and bad images in prediction part. So you have to predict on multiple images, unknown images, and then you have to check if it is predicting correctly, your model is predicting correctly, then your image is like, it's a good case. If it is not predicting correctly, then it's a bad image or bad case. So if all of you are able to do up to this part, can we proceed further? I have to cover some more things. I have to explain how you can save your trained model, and then, or you can save the trained weights, and similarly, you can save the weights as well. So when your model is trained successfully on a large data set, then your model is ready to work on real-time basis. The trained model is ready now. No need to train it further. So in that case, you can save your model, or you can save your model's weight. So both the ways you can work. If you will save the complete model, the model structure as well as the trained weights will be saved in the file. If you only save the weight while creating a new model, while you are working on real-time prediction, you have to first create the model. Then you can load the weights in the created model. So let me save the weights of this model. CNN model. First of all, I will save the complete model, then weights. I'm saving model.h5. So your file will be, the extension will be either H5 or HD5 format to store the data. So now you can see it has saved the model. So our model will be saved over here. Let me show you it from here. So you can see this is the file, model.h5 is saved over here. If I want to load the complete model in a new model, so I can write new model is equal to Keras dot models dot load model, and here you have to provide the path. So in our case, the path is model.h5. It is keras.models.load model. Now this is the new model. If I will evaluate the test data on the new model, then the performance will be same. So you can see it is giving the same loss and accuracy as it has given in the CNN model. This is the way you can save and load the models and its weight. There is another way of saving only weights, not the model structure. In that case, you have to create the complete model. Then after model is created in the same way as the actual model, then you can load and save the saved weight. So let me save the weights of the CNN model. CNN model dot save weights dot h5. So you will see here weights dot h5 is there, but if I will load the weights directly to a new variable, it will give us error that no such model exists. New is not defined. So in this case, you need this as a model. So if I will use new model that is already defined with the same structure, if your structure will be different, when you perform load weights, it will cause the issue. No such file or directory. Let me save the weights and then load the weights. Is there? Okay, S I have not written. So now your weights loading process is successfully done. If your layers are not same as the weights you have saved, then you will get the error in the layer mismatch. So that's all in today's lab. If there is any issue, you can ask. Meanwhile, I'll read the question from the chat box. For image segmentation, so segmentation, we will have a separate lab next week for image segmentation part. For multiple image prediction, you can write the model.predict inside a for loop and pass the image path separately in inside the for loop, so you can get the prediction in multiple images. There is another question, Keras is not defined, so you have to import from TensorFlow, import Keras, that we have done in the beginning. There is another query related to data augmentation. As we have already explained you, here you can apply horizontal flip, vertical flip, horizontal flip as true, vertical flip as true, vertical flip as true, like that. You can apply. Make sure your camera is on. Vertical flip, share, zoom, multiple options are there. Like that, you can apply the augmentation part.
So one question you can take from Neha. I'm asking her to unmute. Neha Agrawal, please unmute yourself.
Hello.
Yeah.
Yes.
Am I audible? Yeah. Actually,
Yes.
yeah, Poornima, I have one doubt. Like when we are doing epoch, so in between some epochs, we will get very good training accuracy and validation accuracy. But at the end, when all epochs will be completed, sometimes it will get reduced. Maybe like in between epochs, we are getting 93%, and at last we will get 90%. Okay. So what accuracy will be considered?
Ma'am, the last one will be considered, but there is another way. In Keras, callback sessions are there. So here you can give another parameter says callbacks, and will be help you to save the
best weight.
best weight. Yes. Then
Okay,
it
and
will be better. But when your model training is done, then you have to load the weights. Then
Okay,
only it will predict on the best weights.
Okay. Thank you.
There is some more question, ma'am. Ensemble learning can be implemented. Yes, you can do it in Keras. If you have model accuracy.
Yeah. Can you please
Yes,
show the
ma'am.
output? We will be doing that. Yeah. Tomorrow.
Ma'am, what is the question? Conv output. Okay.
Conv output.
The feature maps. Yes, ma'am. We will explain tomorrow.
Justin Varghese Saab, he wanted to ask. Will you please ask the question?
Madam, the question is little conceptual question, madam.
Yeah.
Madam, the ReLU function we have 0 or maximum, right? Maximum, right? 0 %, right? ReLU function. How will you make the differentiation, ma'am?
Pardon?
Say for example, max of Z. How we will make the differentiation?
So differentiation, it is not differentiable only at one point, right?
Yes, madam.
Everywhere
Differentiable
else
only
it is differentiable.
in 0 it is not differentiable, and
Yeah.
at only the other spaces. And can you please show how we will differentiate? Because you are from mathematical background, you can very easily show that. Do we apply limit or how we will differentiate for back propagation of local gradient?
That's, yeah. So it is almost everywhere differentiable. Almost everywhere differentiable. So this we can use that concept of almost everywhere, right? So
can you make a simple function and differentiate it and show, ma'am?
Hello.
Any max function. Maximum function.
Hello, I'm not getting
any
this voice is echoing. I don't know the reason, so we are not.
Pardon?
Getting...
Voice is echoing. Actually, let me.
Madam,
yes, ma'am.
Madam, take the max of x or max of z, and can you please differentiate and show, ma'am, just for the sake of an example.
I'm not getting you, but anyway.
You got the point, ma'am, because
sir,
we are applying back
propagation. Your voice is echoing actually. So can you just there must be some device close to you, so your voice is echoing. Poornima, will you unshare your screen here?
Okay, ma'am. Can you hear me now, ma'am?
Better. Okay? Yeah, better.
Madam, the ReLU function, how we will differentiate, ma'am? Can you give the example? One example, can you give, please?
You know, I think this is the graph, right? So
function,
it is not not differentiable only at this point.
At 0. At 0. Right.
So your fx is equal to x for x greater than or equal to 0, and is 0 x less than 0.
0. Yeah, right.
So I take these are known as, you can call them, like, because it is almost everywhere differentiable, you can call them as Frechet derivative also. There is a mathematical concept. So what we do is that df by dx you can define as, say, 1 for x greater than or equal to 0. You can define, like here we can give any value, right? This is the point x is equal to 0 where it is not actually defined. But you can extend this for 1 point and a 0.
Okay.
Right. So the derivative will be, in that case, if this is the function, the derivative will be this will be. So here it is not defined. At this point, it is not defined, but you can give the extension either from left or from right.
I feel there is, madam, actually that Z is the net value, that X is the net value. So we are differentiating it with the weight actually. Correct, Norma? Correct. Am I correct?
Pardon? Yes, yes. Differentiating
Madam,
with respect to weights. Yeah.
Weights only, no. Wait, so how can you give a small example of a single neuron, input neuron and output neuron, a single value or something? Can you just
So you can
give
say
me the...
that you have here W1
Because I am a teacher,
X1
so
plus
that's it.
W2 X2
Yes, ma'am.
plus B, right?
B.
This
Yes, right.
is what? You
Okay.
take the derivative of this. So here I apply ReLU, right? So
Okay,
this
yes.
ReLU will be equal to max of this quantity, let me call it L, and 0, right?
Yes, correct.
And then you
correct.
take the derivative
With respect to weight.
like del by del W1, right?
Yes.
So del
Yes.
del by W1 will be equal to, right, X1 if W1 X1 plus W2 X2 plus B is greater than 0.
Then, yes, right.
Right? And will be 0 otherwise.
Okay, so.
This is with
Okay,
respect to W.
thank you very much, ma'am. Thank you very much. Okay.
There is another question on 27th. I'm not able to give MCQ as I am in an interview panel from 9 a.m. to 1:30 p.m. Is there any way I can give it before 9 or so we will change the time. No problem. We'll change the time. Maybe we can keep it 3 p.m. Any other question? Otherwise, we'll close the session. So if there are no questions, then I thank once again Poornima. No, there is one ML for CV. ML for CV, please write. You should have what will be like.
Madam,
yeah, 11 a.m. I also feel is convenient because 3 p.m. will be. So what will be the time of the quiz? 11 a.m. as I told. ML for CV.
Madam, good evening, madam.
Yeah, please. What
Madam,
is your name?
sometimes what happens, though we get...
What is your good name? First tell me.
Madam, good evening, madam. Myself,
Good evening.
Chapala Maharana, madam.
Pardon?
Mrs. Chapala Maharana.
Okay, fine.
Madam, I want to ask that though we get 100% accuracy, sometimes some image become misclassified. So why does it occur? Especially for image data.
Ma'am, you are muted. Maybe you are asking. Maybe you are saying something, ma'am.
No, I didn't get. I'm sorry.
Madam,
Okay.
sometimes during
What is the
data classification, though accuracy is 100%, some images get misclassified. So I want to know why does it occur?
something gets misclassified
Some image data, I mean, misclassified.
in the test set. Some image may be misclassified.
Yes, ma'am.
Okay. So if some images are misclassified in the test data set, that is like on the trained data set, it has basically so much over fitted itself that it has learned only the characteristics of the training data, nothing else. Nothing else. So in that case, what may happen that it is just like, you know, when you teach in the class and some 10 questions are given and the boys or the students will only be doing those 10 questions and they will forget about any other question. And then when you ask a different question with a different pattern, not the same pattern. So some of them may do very well. They may understand the pattern and they may attempt the question differently. But some of them will, because they have not applied their mind to learn the variations in the pattern. So they will not be able to do that. So it's like that. So machine learning is algorithm is just like you are memorizing. It's a memorizing algorithm. And if you let it memorize only the data characteristics of those, say 200 data, it may misclassify some other data samples.
Yes, ma'am. Thank you, madam. Madam, I have one more question.
Okay.
Madam, is ensemble learning included in this session?
Actually, your voice goes down, so I can't hear you.
Ma'am, she's asking ensemble learning we are going to explain or not?
No, not in this. Perhaps Santosh Tripathi may touch upon ensemble learning, but mostly I don't think we have any session on that. I'll request Santosh to give you some examples.
Some basics at least.
Hello?
Yes, ma'am.
Okay.
At least some basics I want. If some basics are included,
there are certain sessions where we consider like recent trends in ML for CV. Perhaps somebody will cover there. Yeah.
Okay, ma'am. Thank you, ma'am.
Okay.